The horses want more carrots. Oh, hi, I'm Kenan. Welcome back to my fast paced series on the hardest digital SAT practice problems. I strongly recommend starting with the first video in this series, which you can watch by clicking up there. In this video, we're studying mathematical expressions, not facial expressions. Let's go! Solve your math problems. Now, tap pause to try problem 1 on your own. Yuck. Just yuck. There are instructions here, but I find them confusing. In fact, I rarely ever read instructions anyways. That's why my IKEA furniture only has 3 legs. So, I'm just going to follow my trust your eyes, trust your instincts strategy. I know how to do math problems. So when the instructions are too confusing, I just do the math problem and try to figure out what the heck they're talking about later. Whenever you see a problem involving radicals like this one, you have to remember the rule for turning radicals into exponents. You should probably write this down. If you have the nth root of a to the m power, that is going to equal a to the m over n power. For those of you who've had calculus, you're probably used to doing this every single day. But for the rest of us mere mortals, we might just need a little practice. So here's a quick example. If you have the third root of x to the 7th power, it's going to equal x to the 7/3 power. The way I remember that is that radicals terrify most people, and fractions terrify most people. These are the terrifying numbers, so they must be the same number that moves back and forth. Years of experience have taught me that whenever I see radicals, I'm going to change them into fractional powers. And whenever I see fractional powers, I'm going to change those into radicals. So get ready to make the conversion either way, from radicals or to exponents. But I promise you, if you see one, you're going to have to change it into the other. All right. After that little review, let's get back to our regularly scheduled program. The 5 out in front is just sitting there. Pretend it's like a smelly, dirty sock, and we're not going to touch that. We need to take the 4th root of 81. So what number times itself 4 times is going to equal 81? It's 3. Because 3 times 3 is 9, and 3 times 3 makes another 9, and 9 times 9 is 81. So 3 to the 4th power is 81. So that's not so terrible. Now, we need to find the 4th root of x to the 4th. That's just x. If we wanted to, we could rewrite it as a fractional power, and it's going to be x to the 4 over 4, which is just 1. So that's x to the 1st. Let's head back here to the 5th root. What number times itself 5 times is going to equal 32? Well, it actually has to be a pretty small number, and it's just 2. My years of experience have taught me it's almost always 2 or 3 on the SAT. You should probably write this down and make sure you memorize the powers of 2 before you take the SAT so that you can instantly recognize 4, 8, 16, 32, and 64 as being 2 to some power. The last thing to do in this problem is this x to the 32nd power. Let's rewrite this using fractional exponents. Hopefully, you realize that is x to the 32 fifths power. Well, that's not very nice, but I'm not scared. Are you scared? So we have 5 times 3 times x times 2 times x to the 32 fifths power. We can multiply in any order. So let's do 5 times 3 times 2 and get 30. Now we need to simplify the x's. How do you do that? If you aren't sure, let me give you a little dadvice. Just pretend there aren't fractions there. Just cover up the denominators for a second and ask yourself if you know how to do the problem if there aren't fractions. The SAT knows that people and horses too always do worse when there are fraction problems. Do you know what x times x to the 32nd power is? If not, you should probably write this down. The rule is when you multiply, you add the exponents. So it would be 32 plus 1. Of course, this problem is not 1 plus 32. It's 1 plus 32 fifths. Do you remember how to add fractions? If not, you need to see me after class. And you should probably write this down. To add fractions, you need a common denominator. I'm going to slip a 1 under here, get a common denominator of 5, and we have 37 fifths for the final answer. Now that we're done doing the math problem, it's time to try to understand the instructions, if it's even humanly possible. I guess B is the number way out in front, and A is the value in the exponent. If that wasn't enough, the score crushing sociopaths at the SAT want us to find B minus A. So we have to take 30 minus 37 fifths. When will this nightmare ever end? Again, we're going to need a common denominator. So 30 becomes 150 fifths. We take away 37 fifths, that leaves us with 113 fifths. We did it. As a quick review, when you see radicals, get ready to switch them into exponents with fractions. The number in front of the radical is the terrifying number, so it creates the fractional exponent. When you multiply, you add the exponents, but to add fractions, you have to get a common denominator. Also, make sure to memorize the powers of 2. Now, tap pause to try problem 2 on your own. This problem is not so terrible, but year after year, I see students freeze up on these, and I wanted to make sure that I gave you a quick reminder. Is this an addition problem? No, not really, because you can't add these things together because they are not like terms. You can't multiply anything together, but you can only add terms if they have the same variables and exponents. These do not. It's sort of like adding fractions. You can only add them if they are alike. See the x squared there? It's another factoring problem. How do you factor it? You take out a greatest common factor, or GCF. Hopefully, you can see that you can take out 16. So it's definitely answer choice C or D. How many x's can you factor out? Both answers say x squared, so clearly it must be x squared. But what's going to be left behind when you take out the x squared? Well, x to the 14th here and no x's back there. So the answer is D. Just for a quick review, as we saw in the first problem, when you multiply, you add the exponents. So if you wanted to work backwards from answer choice D, you can quickly multiply the 16x squared, y squared back into the problem. When you add the exponents, you'll get the original problem. Which reminds me, don't forget to look for a greatest common factor on the SAT. Okay, we have one problem left. If you just got a little bit smarter, please like this video. And because I can't explain 12 years of math in 10 minutes, please subscribe so that you won't miss any videos. And most importantly, improve your SAT score. Also, don't forget to share with your friends. Now, tap pause to try problem 3 on your own. The first thing I notice here is the x squared. Whenever I see an x squared, I say, it's another factoring problem. As always, make sure to check for the GCF in a factoring problem. But this doesn't have a GCF because some idiot put a b right in the middle of our problem, and none of the terms all share a common factor. The SAT usually gives you a hint on how to factor a problem when this first number is greater than 1. And you can see down below, they're telling you to put the 12 in here. So we're halfway done. Now, we need to factor negative 22 and make sure that the two factors add up to B. Well, because some idiot put a letter in the middle of our problem, this is an alphabet soup problem. They're trying to make your life difficult, but noticing that this alphabet soup problem should give you the courage to say, the SAT is not the boss of me. So I'm going to pick whatever I want to for B. In fact, I'm just not going to worry about B at all. Instead, I'm just going to factor the negative 22 as positive 11 and negative 2. If we FOIL this back out, B would be negative 13. But the question doesn't even care what B is. So I don't care either. Raise your hand if you don't care what B is either. The question is asking which of the following must be an integer. Do you remember what an integer is? If not, you should probably write this down this time. An integer can be 0, positive or negative, whole numbers, and no weird stuff. What's not an integer? The weird stuff, like decimals, fractions, and irrational numbers. Let's look at the answer choices. We already figured out H is 12, K is 11, and J is 2. Answer choice A is wrong because 11 divided by 12 is some terrible decimal. That's not an integer. Luckily, answer choice B works because 22 divided by 11 is 2. With hindsight, it obviously had to be choice B because K must be a factor of 22. So no matter how we chose to factor 22, 22 divided by one of its factors is always an integer. Those sociopaths at the SAT sure have a twisted sense of humor. Thanks for watching. I will see you in my next video. A link to the hardest problems and paper practice tests is in the description. Please practice.